Dividing complex numbers. Though this comes up more formally later, some questions may require you to simplify an expression like a plus bi over c plus di. To do this, multiply the top and bottom by the conjugate of the denominator to make the denominator real. So we've got a plus bi over c plus di, and we're multiplying by c minus di over c minus di. So we can see that we've got the conjugate of the denominator. Now effectively, we're multiplying by 1. So we're not changing the value of this, just the form in which it's written. So that gives us a plus bi multiplied by c minus di, which we know how to do because we've looked at multiplying. On the bottom, we get c squared plus d squared, which is entirely real. Now, what we're doing there is making use of a difference of perfect squares. So if we have that and we expand it out, we're going to get c squared minus cdi plus cdi minus d squared I squared. So we can see that these cancel, the cross terms cancel, and then I squared is -1, so we end up with c squared plus d squared. So we can always do this. We don't need to do all the expanding because we know those terms are going to disappear. Then we would expand the numerator. This is called realizing the denominator. It's like rationalizing the denominator when we're using surds.